So far in this series of lectures, we've looked at taking a blank disk, putting a partition on it, and then putting a file system on top of that partition, and then mounting it and thereby making it accessible to our users. Well, after all that's done, then comes the maintenance phase, where we have to watch the disk. If there's a problem with the disk, is the space running out on the drive? All that information is important when dealing with a Linux operating system. What we're going to look at next are the tools, some of the tools that we can use to help us maintain the integrity of the file system we've created. We'll look at FSCK, which is the utility you would use to check the disk if it was corrupted in some way. It also has other functionality which we'll get into. DF and DU allow us to check space availability on the drive or in folders and files on the system. LSOFF is what it stands for as list open files. If we're trying to unmount a file system and it won't unmount because it's in use, well, what's using it? And we can use LSOFF to see that. Then FUser, same function. We can see what user has that file open on the file system. And then dump-b2fs and tune2fs. We'll use both of this. Dump-b2 basically shows us what the current status of the file system is, or the parameters set on the file system, gives us lots of good information. Tune2fs allows us to then modify that information if we need to. And we'll show you a couple of fun things you can do with that. All right, so let's get to the command line and play around. The first two utilities we'll look at are DF and DU. They help us manage the space usage on our partitions. First command, DF, and you'll see me use this quite often in class, allows me to see the amount of space that's being used on my currently mounted partitions. If I type nothing else but DF here, I basically end up with 4 or 5 columns. The first column shows me what file system I'm looking at, what dev file it is associated with, so you can see SDB1 down here and so forth. Total space available, right? The total size of the partition. How much of that space is currently being used, what's available, what's still available on the system. It gives it to me in a percentage of disk space, and then it shows me where it's mounted under root. Now, while this is great, one of the first things we want to do is put it in a format that we can read a little bit better. So I'll type df-h for human readable and press enter, and sure enough, now we can recognize some of these numbers. So for instance, we'll go down here to SDB1. We have a 200 meg partition roughly. We have 5.8 megs in use, 82 available for a total of 4%, and it's mounted under /MNT1. This is good information. Now we can also, there are some other options that we can pass to DF that will help us gather more information about it. For instance, what type of file systems are they? I cannot see that from here. All I can see is disk space, where it's mounted, and what the dev file is. If I want to see the type of file systems they are, what I can do is put the capital T here, and that will show me the different file systems. And what I'm going to do just to clean this up a little bit, I'm going to actually grep it and look for SDB, because these are the ones we're going to be working with in this section. So here you can see I still get the same information I did about size and space usage, but now I also have what file systems they are. And as you can see, we have ext3, ext2, ext4, and vfat. Remember, ext2 is non-journaling. ext3 is journal. Now this is interesting because you can actually see there is a difference here. If you look at this space in both here and here on those first two, mount 1 and mount 2, SDB1 and SDB2, there's nothing in there. I haven't created anything except formatting it. And just by formatting it, you can see that ext3 uses a little bit more space, and that's because of the journal. ext2 still uses some space to hold information about the file system, but it's not as large as ext3 or ext4. So that's an interesting face, and that's showing me the amount of space that I actually have. We're dealing with blocks, and we're used to thinking like that, how much space I have left on that disk. But as we remember from a previous lecture, the system also allocates things called inodes, which are how files are referenced. Remember, when we create a file, that file actually has a number, and that's how it's tracked in the file system, not by the name that we give it. So if I want to see the number of inodes available still, I can come back up here and put an I after this. So now this gives me the same information about what type of file system, but it shows me the number of inodes available. So how many files can I create? So for instance, I can create 51,000 files on that 200 meg file system. I've used 11 of them and I have a heck of a lot left. It's kind of interesting. You'll notice the VFAT down here says it has no inodes available, and that's because it is VFAT and not a traditional true Linux or file system. It does still use numbers to track, kind of just creates them as it goes along. The thing to remember about this is you will run out of space, block space, more than likely long before you ever run out of inodes on a file system. Now let's get out of here for a second. Let's go back and we'll get rid of the I, because we're not concerned about that. But if we look at this, here's this partition right here, Mount 3, the VFAT one, seems to be running out of space. And what we want to find out is, 82% of that drive is gone already. My gosh. We need to actually find out what files are taking up all that space, and that's where the du command can come in and help us out. So df allows us to see the big picture, how much space is left available on the disk. Du allows us to go in there and actually find out what files are causing the problems, or what files are the largest files in there. I'm going to cd into Mount 3 here, and if I just type du from here, what I get once again is that format of blocks, which I don't want, so the first thing we'll put, of course, is an H here. And now I can see what directories underneath this mount point are actually holding the information. By default, du will only give you back information about directories. It won't actually show you file information. If you want to see file information, you want to literally see what files are in here, not just the directories and the size of the directories. You have to add another option. Now, if you just want to see total size on a particular directory, you can do something like this, right? And that, put in the human readable, and that'll give us the total size, but we get that same output up here, right? We can summarize the complete size of that, and we can narrow it down to a directory if we wanted to. So if I just said dir1 from in here, I can just look at that particular directory from within this one. But if I want to see what files are causing the problem, so what files are the largest files in here, I can type du-a human readable and press enter, and now I can see not only the but I can see the files that are in that directory. So if we look here, we can see that there's a bunch of files, empty files up here, and then we have a file called big file 1 that's 10 megs, big file 3 that's 30 megs, and then we have subdirectories, and probably the biggest file of them all is this big file 7 over here, which is 70 megs in size, and so maybe we want to get that out of there and free up some space if we need to. So the df and the du commands, two good commands that you can use to really help you see what's going on in the file system. Next, we'll look at ffck or FISC, see how that can help us maintain our file system.